We're changing stick shift drag racing yet again. Slipper clutches, drag guys, you know exactly what's in front of me. This is an 8-inch twin. This is a Defiant 11-inch. These are some of the common clutches used in this outlaw stick shift drag racing. Also some of the common clutches used all around the world for any kind of stick shift drag racing, whether it be heads up or bracket racing. If you clicked on this video and you're watching this, you probably already know how these things work, but I'm just going to give you a brief description of the pressure plate. Has what's called base pressure. You can use these screws along the pressure plate to adjust the base pressure in the clutch, and then the levers themselves have weights attached to them. That way at RPM or higher RPM, the clutch gets more aggressive and has more pressure with higher RPM. That's how they work. That way the clutch can slip off the line and still grab when it gets to a certain RPM and have plenty of clamping force to hold the car's power down track. The operation of this clutch is 100% reliant on the functionality of these levers. Therefore, you don't want anything interacting with these levers because it's going to take away from the functionality, change the functionality, or make it inconsistent. That being said, the main problem with using a hydraulic system on a slipper clutch is that that bearing is always trying to touch these levers. And what that can do, again, is create inconsistency in clutch tuning, and it can create kind of some false info or data from the past, depending on what happens with that release bearing during the pull. Clutches like this one, you can see that they have actual travel in the levers themselves. What that's going to do is it's going to push the bearing back away from the pressure plate levers themselves, which can create an air gap with the aftermarket units. And you think, well, that's fine, I'll just use a factory one that'll have a spring and it will maintain that contact. Well, that becomes a problem because you don't necessarily want that to happen. Again, these levers are very, very important to the operation of the clutch, and if they're interfered with in any way, they don't do exactly what you're expecting them to do. The solution for everybody in the past has just been to run an aftermarket release bearing and deal with it. So if the fingers push the bearing back off the next time you go to push the clutch pedal in, it doesn't mean it's going to disengage. Sometimes it will, sometimes it won't. Sometimes you have to pump the pedal depending on how much actual travel your levers have. This can cause staging problems in drag racing. It can cause problems where at the end of the track you're trying to get the car out of gear and you can't because you're having to pump the clutch pedal. I've seen guys doing burnouts and not be able to get it out of gear after doing a burnout because of the clutch itself. And it's very, very prominent in cars that are still using synchronizers with a slipper clutch because they are harder to get out of gear than transmissions with dog ring engagement. After years of hearing guys complain about these common problems, we decided to tackle it head on and come up with a new release bearing solution for the hydraulic guys to completely change the game. What you're seeing here is our new retractable release bearing. And it's very counterintuitive to the way that a traditional release bearing system would. With a normal hydraulic release bearing system, you want that bearing to be constantly in contact with the pressure plate levers, because if you ever have an air gap, you're going to have clutch disengagement problems. And the reason behind that is once the bearing is in a free-floating state, it has to move to get back to those levers, and there's no resistance in that happening. So what that does is creates a dead pedal feel, and it also creates inconsistent shifting because, again, your master cylinder is only moving the release bearing as far as the release bearing is being told. So inconsistent shifting issues. Unlike a factory release bearing system where you want the bearing to constantly be contacting the pressure plate levers, with these systems, you don't really want that to be the case. You want to get the bearing away from the levers. That way the levers can do their job as they're intended, which is to move and create force on the disc to give it more clamp load. So currently when guys are using aftermarket release bearings on these clutches, they're dealing with the problem of the bearing free-floating its way back after the fingers have pushed it back, and then having the issue of not being able to get it in or out of gear the next time they push the clutch pedal in after they've revved this up. Honestly, it's so bad that if you have it out of gear or in neutral and you just rev the engine and then you push the clutch in to go in gear, 9 times out of 10 it's not going to go in gear because the pressure plate has moved the release bearing to a point where you don't have enough travel to disengage the clutch anymore. With our new patent-pending design, we have created a self-retracting release bearing. That way, when you release the clutch pedal, the bearing itself retracts away from the pressure plate levers, and there is no more interaction. The plus side of this is because this is a self-retracting system, That means that it's always preloaded. When you set this system up with the proper air gap and the proper master cylinder, you're always going to get the same amount of travel from the slave cylinder. So the bearing retracting itself away from the levers obviously gives it the ability for the levers to do exactly what they're trying to do without interference from anything. If you're relying on your pressure plate to push your release bearing back, that means you're also relying on the rest of this system to be consistent every time and be the same every time, and it's not going to be. If the temperature of this is different, the viscosity of the fluid's different, the temperature outside's different, any of those things will make the return speed that this thing can push the bearing back different, meaning that it's going to be different every time you launch the car. So if you have cold fluid in this system, and if you have hot fluid in this system, they're not going to do the same thing both times, no matter how many times you adjust the clutch to where you think that it's going to do that. It's just not going to be able to. With this system, it doesn't matter anymore, because now when you let go of the clutch, this moves completely away from it, and this does what it needs to do. With this new drag race release bearing after launch, now you know that your pressure plate is doing what you're adjusting it to, and you can have more consistent adjustments. So much like our other release bearing systems, this one has a double support system. It's double sealed. It does have a wiper seal to prevent dust from entering in. But again, the key component being that this is a retractable system. Something else to note is that it has internal stops, so you can't physically push this thing out and past the end. I know a lot of guys at the racetracks, you'll be in a hurry, and from time to time you'll have problems where you put the system back together and you didn't set it up quite right because you were in a hurry and you didn't measure this right or whatever. And guys have had problems actually blowing the piston out of the ends of their release bearing assemblies. Then you've got to take it all back apart. You've got to hope that you didn't get clutch fluid all over your clutch disc and ruin the clutch disc. And just creates a lot of problems. So this actually has an internal stop built in, meaning it'll only travel X amount before it bottoms out inside and locks up, keeping you from blowing it out. One thing to note is that if you have a mechanical stop on this end, well, then there could be potential for a problem on the other side. If you ever run into a situation where you're bottoming this out at speed and you don't know that you're doing it, you can bend the master cylinder rod, because once this thing stopped, there's nowhere for that pressure to go, and if you build up too much pressure, something is going to give. That's just a common part of hydraulics. That's how it works. There's no bypass in one of these clutch systems, so you don't have a bypass for that pressure. So if you deadhead the pressure, something has to give. When you measure the depth of the pressure plate fingers on a slipper clutch, you need to make sure you're actually pulling the lever all the way toward you, because that's where it's going to be at idle. As you can see right now on the table, laying face down, the levers are all the way down because gravity's pulling them that way. But when this thing's actually spinning at idle, it's gonna move these back to about this point. And I've went ahead and pre-measured this clutch just so you know. This is about 120 thousandths difference between rest right now and where it's actually going to be when it's running. 120 thousandths can be a huge difference when you're talking about your slipper clutch and you're talking about making sure that it's not going to run into this bearing. Because if it runs into this bearing with the bearing bottomed out, well, then you run out of lever travel. When you run out of lever travel, you're going to start slipping the clutch. You're going to burn your discs up. So when you measure on a slipper clutch, make sure you're pulling the lever all the way toward you. That way you get an accurate measurement. We know that when your clutch disc wears, the levers move toward the bearing assembly anyway. That's the reason that you want to have as much gap as you can. At least a minimum of 200 thousandths is what we recommend. Because as that clutch disc wears, that gap shrinks and goes away. And as that gap shrinks and goes away, you run the risk of the levers becoming able to contact a bearing that can't move any further away, again causing clutch slip. This has a maximum travel distance of 750 thousandths, and you can feel free to use that entire 750. So if that means you can comfortably get 300 thousandths of gap, by all means do that. Because the more gap you have, you can have this assembled in your car longer before you actually have to take it out and readjust your height. So the slave cylinder comes just like this with an 8-inch bleeder. Again, we have the option for the long bleeder. You guys are under your car thrashing so much that I don't think you're going to mind getting under to bleed the clutch. But we do have the option for the extended bleeder. It doesn't come with a feed line. Drag car builds are always, something's always custom on them. You're not running a stock master cylinder. You're more than likely not running a stock release bearing anyway. So a lot of you guys already have lines, and you're going to adapt these to the hydraulic system that you currently have. So rather than giving you something that isn't going to work for you, we're going to work with you on what you need and make sure you get the proper thing that you need to connect your system back to your master cylinder. One thing to note with this system is that you do need a minimum of a 7/8 bore master cylinder to get enough travel out of this thing to make it fully functional. So if you go online and order one of these, this is what you're going to get. You're going to get the kit is the release bearing with a bearing and the standard bleeder fitting. There's no lock key on this one to measure because it's always at base. You don't have to lock it out to be able to measure for the shim, which makes it a little easier, especially for at the track adjustments. If you need help with your hydraulic connections, just give us a call. If you're not confident that you'll be able to get it connected to what you have, give us a call. We'll walk you through what we think you need to do. Another option that's going to be available for these is an HD bearing face. So basically an oversized bearing face that's going to be bigger in diameter. And that's to account for some clutches that have a more spread out lever pattern. This is to show the functionality of the retractable style release bearing for the drag race applications. So what I got set up here is I've got it bolted to the front of a transmission. Earlier I made mention of the different style connections that we could make on the hydraulic feed line itself, and this is just one of those examples. What we have here is an F-body disconnect, so basically the same fittings and everything that our F-body release bearing system uses, and it's just adapted to work with the return style slave. And what that means is you can use the factory disconnect. So when I say we're pretty versatile on how these things can connect, lots of different ways we can go about it, lots of different connections we can make, so we can make whatever work to suit your application. So I've got this thing set up on this transmission. I've got a dial indicator put on the face of the piston itself. I took the bearing off for this because with the bearing it actually has some side-to-side rock when you side load it, and the indicator is enough to side load it, so you wouldn't have seen a true number or a consistent number. So we went ahead and pulled the bearing off. That way we can just show this. So this isn't going to show exactly the amount of travel that you're going to want to see out of this. It's just to illustrate how it works, nothing more. Again, you'd want a minimum of a 7/8 bore cylinder to work this unit properly. I do have this set up to where we can use its full entire stroke range, which is 1.1 inches, and you're going to see that it moves the release bearing around 450 thousandths in this open environment. You would see a little less than that travel-wise in a car, in an application where it's actually moving a pressure plate, because it will have to build up a little bit more pressure to actuate the entirety of the travel. So probably going to discount several thousandths, between 10 and 20 thousandths from the travel of what you see here versus what you'd actually get in a car. So I'm going to just push this down and you're going to see how this works. It's pretty simple. This would simulate clutch in. Currently that's 450 thousandths of travel, so that means it's moved 450 from base to full. And this kind of highlights what I'm saying when I say that thing's going to move as much as it's told to move. The master cylinder is going to move that thing as far as it can move by the amount of fluid that's displaced. It's not going to move any further. Adding a shim behind it, it's not going to make that move any further. It's going to move the same amount. Then when we release it, you can see that the bearing retracts itself. In a normal application, what truly retracts the piston of the release bearing itself is the pressure plate, the force of the pressure plate. So in a drag race application, we've already touched on this, the pressure plate itself doesn't have a lot of pressure down toward base or at lower RPMs. If you had a 10,000 RPM two-step, it's making plenty of pressure plate pressure to be able to throw the bearing back. But at lower RPMs and normal driving conditions and lower RPM two-steps, all the return, to push the fluid back through the system into the reservoir, to move the piston itself, all the weight of that assembly, that all gets moved by the pressure plate itself. And with a drag race application, they just don't have enough force to move that thing fast enough to get the kind of reaction times and things that guys are wanting out of these systems. In a normal street application, there's enough pressure plate force to push that bearing back quickly. That's why a factory release bearing doesn't have to have a way to retract itself. So the problem that people have had over the years with drag slaves is that they're using something that's never intended to be used in this manner with their drag race setups. And that's where the problems come from. And that's what this system eliminates, all of those problems. A couple of bonus side effects from this system are going to be faster reaction times, quicker 60-foot times, and a better clutch tuning window. So you're going to have more accurate clutch adjustments. We've already talked about that. But because this thing can move itself and retract itself at speed, it's going to allow the clutch engagement window to be faster. So the time you let off the clutch to the time your car breaks the starting line beams, it's going to be quicker. So you're going to have faster reaction times by nature. Your ability to tune your clutch off reaction or tune your clutch off disengagement better. Now that you're not having to account for another system interacting with your clutch, you can dial in that launch a little better, and you're going to be able to have better 60-foot times as well. To learn more about the drag race specific release bearing, check us out on our social channels. Also check out techperformance.com, or feel free to call and talk to one of our knowledgeable sales staff.